Okay, g'day all, welcome to another bit of C++. The first thing I want to say is another little teaser for my new language that's coming out soon. I'm making an interpreter for a language called Isaac 0.7. It's for NLP or AI. And this is the code for it right here. Yeah, so another viewer sent me a message saying that there was a Wikipedia page up for a language called Isaac, and I just want everybody to know that it's not the same language. And if the viewer happens to watch this video, if they could leave a comment so that maybe I could find that Wikipedia page and yeah, potentially change the name of my language. Anyway, that's the code there for my language, so hopefully that'll yeah, be interesting to read. That's pretty much what the code looks like. This is just very simple code too. It does a lot more than that, but hopefully that's interesting. If you want some more info, then visit the website and Facebook. And on to the rest of the tutorial. So basically today what we're going to be talking about is polymorphism. We've finally reached polymorphism. This is one of the greatest benefits to C++. To polymorph means to change form, and to use polymorphism in C++ is pretty much to write functions and write code that works with different data types. Yeah, it's not the same mechanism as templates, but templates achieve a similar idea. So if you're used to C++, you've probably heard the term templates a few times. Maybe you already know what templates are, but yeah, I just want to make it clear that we're not talking about templates here today. Okay, so the basic objective, what are we trying to do? So let's say that what we've got is a game and there's a bunch of different monsters, NPCs, there's probably a player wandering around, there might be water and other inanimate objects that can move in our game, but all of the objects in our game, once per iteration of the game's loop, what we want to do is tell them all to move. So we might have them all in an array or other list of some sort. And what we want to do is pretty much for each object in that list, every iteration of the game's loop, we want to tell them to move. And so they all run off and move and do their own thing. You know, the zombies will shuffle around, the water will flow a little bit or whatever. But this is the function down here that we want to make. Void call move, and then it takes an object star, that's pointed to an object, and we just want to call the move routine for all of the objects in the game. And we want to loop through all of our objects and call that. And the point is that from this method just here, this call move method, well, this won't actually be a method, this will probably be a global function, but from this function here, we don't care if if this O variable just here, we don't care if it's pointing to a monster or an NPC, we don't care if it's pointing to another inanimate object or the player himself or herself. All that we care about is that the object can move. Yeah. And that's pretty much what polymorphism comes down to. That's what polymorphism lets us do. So for all of the objects, there might be 1,000, 1,000,000 of them. They could all be completely different. We could have zombies, goblins, wolves, whatever you want. But every one of those objects could potentially have its own move routine, and this call move function just here, if we set it up right, is going to call the appropriate routines for all of them. Okay, so just a little bit of a word on casting. You can always treat a child object as its parent, but you can't always treat the parent object as the child, unless the parent object happens to be of that type. Then, you know, you're probably not going to run into too much danger, but, you know, how do you know that the parent object is of that type? We'll probably go over that a bit later. But the reason behind this is that the child class itself might actually have more variables physically stored in RAM that the parent class doesn't have. But the child class definitely has inherited at least all of the parent's variables. So you can always treat the child object as a parent, but not vice versa. Derived child classes are their parent classes, but the base or parent classes are not necessarily their child classes. I hope that makes a bit of sense. And then a bit of arcanity down here. If you play around with pointers, you can cast whatever you want to, whatever you feel like. But it's not always wise to do that. you wanna yeah, be sensible. Anyway, parent pointers to child objects. Yeah, this is fine too, and this is really one of the most fundamental things that allows us to do polymorphism. So a base or parent pointer can be made to point to a derived or child object. This code just here is only really sensible if the parent class here is the parent of the child object. So I'm thinking just here that the child class inherits from that parent. And it's a little bit weird, so you might ask, like, what is the type then of the parent pointer P just here? It is a parent pointer, parent star P. Yeah, it's definitely a parent pointer, but it's pointing to a child object. So I don't know, in another way it's kind of a child pointer as well. A little bit weird. Anyway, we'll see how it all works. It's not that hard. We're going to code at the end. Okay, so virtual methods. How do we actually polymorph this? How do we polymorph? I wish. I wish. I don't know how to really polymorph, but I'll tell you how to do it in C++. Methods which are marked as virtual can be rewritten in the child classes. So in the parent class, if you mark a method as virtual, it means that any child classes that derive from that parent are free, if they want, to specify their own code for those functions. They don't have to use their parent's code. They can, rewrite their own code. So you can make two methods with exactly the same name, one in the parent and one in the child class, and you mark the parent's method as virtual. And the child class is free to do its own thing. The code that the child class runs doesn't have to be related at all to the parent class's method. What you can do in the child class's method is mark it with this specifier here, override. Yeah, override means that you're overriding a virtual parent function. And the override specifier itself is actually optional. I think what you should do is always use override. Whenever you're overriding a virtual method from the parent class, you want to use the override specifier, just because it makes reading the child class's code a little bit easier. You can be sure that any methods which have the override specifier by their names must have been virtual functions in the parent class. Okay, on to abstract methods and classes, or purely virtual methods, these are sometimes called. So we're just going to run through all of these terms and have a good look at an example at the end. We don't actually have to define the body of a virtual function at all. What we can do is mark a method as virtual and not specify a body at all in the parent class, but then the child class itself can specify the body to a function, if it feels like. Or the child class itself would be abstract. So these methods, these purely virtual methods or abstract methods, these methods with no body in the parent class, are really, really useful. Any class that's got one or more of these purely virtual methods, the class itself is called abstract. It's an abstract class, and you can't make an instance of an object from an abstract class because the blueprint is pretty much incomplete. So the blueprint to a parent class that's abstract doesn't actually specify the body of one or more of the functions. So the blueprint itself is incomplete, and you can't make an instance from that blueprint. But what you can do is make a pointer from that blueprint, and that pointer can point to the child objects or the derived objects. Abstract methods are a little bit like a contract. Yeah, I quite like this description, really. So when you make an abstract method, what you're saying is that any class that derives from this parent, this abstract parent, any class that derives from this parent is able to do this method. We don't care what the method is, but the child classes can do this method. That's pretty much what you're saying with an abstract method. Otherwise, the child class itself is abstract. Yeah, and you could inherit from that, child class, and specify the methods down there if you want. It's completely up to you. But the syntax to make an abstract method is pretty simple. You just say virtual, and then the return type of your function. I've used void here, for example. And then some function, that's just your function name, or your method name. Then you've got your parameter list, but then the important thing is equals 0 and a semicolon at the end. So this equals 0 here changes it from just a virtual method into a purely virtual method, or an abstract method if you like. And at the same time, it makes the entire class abstract. The other important thing to be careful of is that you don't specify a body under here. Yeah, you don't specify a body to a purely virtual method. We'll see this in action in just a moment. Okay, so a class that has no methods at all that aren't purely virtual, or a class with nothing but abstract methods, is called an interface. So we might make one of these in the coding in a minute. And all we're saying with an interface is we're just providing a list of purely virtual methods, and we're saying that all of the classes that inherit from this one are able to do all of these functions. We don't care what the functions are, but the child classes or the derived classes that derive from this parent are able to do all of these things. Yeah, so interface is just a word for a class with nothing but purely virtual methods. Okay, and onto the code. So I'll just hit escape and we'll get a bit of Visual Studio happening. Okay, so here's a little list of things that I'm about to do, so maybe you want to have a bit of a look at those and have a go at them yourself if you're pretty used to this kind of coding. Otherwise, I'll show you how to do it in just a second, or how I would do it anyway. Yeah, a bunch of little things to do. Little activities. Alright, well let's get started. So the first point, make a parent and child class called animal and lion. Alright, here I am in C++. I want to mention too that if you're using Linux, just get rid of conio.h and get rid of getch and you should be fine. Yeah. Other than those two things, I don't tend to do anything that's Windows specific, in these tutes anyway. But anyway, back to the point, we had a parent class called animal and a child class called lion. There we go, so that's done, except for a semicolon. Okay, so there's the parent class, animal, and there's my lion class, that's the child class, and it inherits from the parent class publicly. Okay, make an eat method in each of the above classes which prints a unique string for the animal or the lion. Okay, so we've got to make two methods, one in the animal class. I'll make these methods public all. Okay, so void eat. And the eat method for the animal, I might say cout the animal eats something. I'll just put like a ... and question mark because the animal eats something is pretty irrelevant to everything. Like we don't even know what type of animal it is. Which is where abstract classes will come in a moment. But anyway, the lion. Well, when a lion eats something, I might say cout the lion takes a big gulp of wildebeest. Wildebeest. It might be beast, I think. I don't know, so I'll put a question mark there. Okay, so regardless of the spelling of wildebeest, which is not really relevant to what we're doing here, I could look it up. What we've got here is two methods. Yeah, one's called eat in the parent class and one's called eat in the child class. So the next activity, call these methods and see what happens. What we're going to do, come down here to main and make an instance of each of these objects. So animal A and lion L, and we're going to call the methods. So animal eat and lion dot eat. And then we're going to run and see what happens. Well, there you go. There you go. So when the animal called its eat method, it printed out its string, the animal eats something. That's up here in the parent class. And when the lion called its eat method, it printed out the lion string. So the lion takes a big gulp of wildebeest. Which is pretty much what you'd expect, really. That's, yeah, it's fair enough. Make a call eat method which takes an animal pointer and calls the eat method. And pass the animal and lion objects to this method and see what happens. Okay, so what we want here is we want to try and do a bit of polymorphism. We want a call eat method which takes an animal pointer, I'll just call it A, and it calls with that pointer the eat method. Okay, so that's fair enough. But what we want to do is pass our animal first of all, so call eat and just ampersand A to take the address and pass it as a pointer. The next one is the lion, so we'll do the same thing, call eat ampersand L. Yeah, you often want to pass around pointers with objects. You don't want to pass around the whole object, you just want to pass around pointers because it's quicker. But the big question is, and drum roll for this, what's going to happen? So here we're calling the eat method, and it should just be calling, or we're calling the call eat function, and it should be calling the, what, the animals eat method, then the lion's eat method. But look at that. Look at that. The animal eats something. The animal eats something. So what has it done? What has it done? It's forgotten that the lion is a lion, and it's decided, because of this pointer down here, this animal pointer, it's decided, well, you know, he must mean call eat twice for the animal class. It's forgotten that this second pointer here we're passing is actually a lion. Yeah, that's what it's done. It's printed the animal eats something twice, so that's no good. We want this method here to treat the lion like a lion. I know that's an animal pointer, but you know, we want to be able to pass any type of animal, be it a lion or an ant or anything at all that inherits from this animal class. We want to pass it to call eat, and we want call eat to treat the animal like it is. Okay, so how do we do that? Well, this next one here. Mark the methods as virtual and override, and call the two eat methods again. Okay, so what we got to do up here in our parent class is mark eat as virtual. And the virtual keyword means that the child classes that inherit from this parent may or may not override the eat method. Well, we know that the lion class does override the eat method with its own eat method, but we can just be extra sure that everybody knows it by placing the override specifier there beside the parameter list. So override is completely optional, but I'm going to put it there because it makes it easier to read. But now the question is, if we don't change this code down here, so we call the call eat method twice, passing once an animal pointer and the next our lion pointer, what's going to happen? There we go. There we go. So we did some polymorphism. We did it. We polymorphed. What it's done is printed the animal eat method for the animal pointer, but it's remembered that the lion pointer here, this second call to call eat, is actually a lion pointer, and it's called the appropriate eat function. So what we've done there really is extremely cool. It's extremely powerful and very important. What we've done there is, with exactly the same code, this code right here, with exactly these 4 lines of code, we've called 2 different functions. Yeah. The lion called the lion's function, and the animal called the animal's function. And that, my friends, that's what polymorphism is all about. Anyway, let's just close this down and see what else we've got. Okay, so mark the methods as that. Yeah, we did that. And the next one, mark the animal class as abstract. Okay, by making its eat method purely virtual. Alright, let's do that. So how do you make a method purely virtual? Well, first of all, what we're saying with this, when we make a class abstract, we're saying that it doesn't make sense to create an object from this. Okay, so that is now a purely virtual method. Virtual void eat equals 0, and there's no body to the method at all. So this parent class now is abstract. The animal class is abstract. So what does that mean? Well, it's got some pretty important implications. For a start, we can't build an animal object. Look at that down there. So it cannot instantiate an abstract class. So if we scroll down, we'll see what it's talking about. There you go. Yeah, animal A, we're trying to build an object of type animal, but you can't, because the the animal class itself is abstract. We've said with this purely virtual function that it doesn't make sense to build a generic animal. It makes sense in our game, you know, or whatever little animal kingdom we're building here. It makes sense to build child classes from the animal class, but not an animal class itself, because that's abstract. So we'll have to get rid of that, and we'll have to get rid of that. If I alt file save. So the answer here is, you know, does the project compile? The answer is no, the project doesn't compile, because the animal class was abstract and we were trying to instantiate an object from it. So fix the project. So we did that. We did that by getting rid of any lines that have anything to do with trying to build an instance of the animal class. Okay, so the next point, add an ant class inheriting from the animal class. Okay, this is going to be unreal. I love ants. Ants are really cool. They always seem to find the quickest path to food. You know, they're clever. They're very clever. It's sort of generative programming. You know, every single ant himself isn't particularly intelligent, but when you get thousands of them, they can somehow find the quickest path to some food source. It's unbelievable. Anyway, I'm not David Attenborough, so I think I'll shut up about it. Here's my ant class, and it's got to inherit from the animal class. I might make it public, so public animal. That's not even close, mate. Okay, that's pretty good. I did that. So build an ant class inheriting from there. Try to create an animal, an ant object. All right, so I already know what's going to happen, but I'll try anyway, just for, well, you know, humour me. Let's try and make an ant object called anti. Look at that. It's underlined it. So it's underlined it, and the reason is because the ant class at the moment is abstract. Yeah, it's abstract. So the ant class has inherited this purely virtual method eat, but at the moment it hasn't itself overridden it and defined a body. So the ant class is abstract. What we would have to do, I think that might be the last point, override the eat method in the ant class. Yeah. Okay, so this is how we make the ant class not abstract. We define a body for the eat method. And like I said before, the override keyword or specifier is actually optional, so I might just leave it off for illustration for the ant class. I'll say the ant nibbles your toes. The ant nibbles your toast. The ant nibbles your toast. Well, there you go. So now we've overridden the eat purely virtual method from the parent class. And if we scroll down, there you go. So now we can make our instance of the ant class, ant-anti. And the final thing was to call eat with both of those two objects. So if I just call the call eat method with an ant pointer, or a pointer to our ant class, what we should get, all going to plan, is well, the lion and the ant eating things. Yeah, there you go. The lion takes a big gulp of wildebeest. The ant nibbles your toast. Okay, but again, what I want to stress, I mean, you know, lions eating wildebeest or ant nibbling your toes, you could easily just type out couts and do that. But the thing is the method that we've used to print those two instructions. What we've done is we've called two different methods with the same code. Yeah, this call eat method just here, because all of the, you know, overriding and inheritance hierarchy is done in a polymorphic kind of way. Yeah, this call eat method here remembers the data types that these animal pointers are pointing to, whether they're lions or whether they're ants or whether they're anything else. It'll remember the data type and it'll call the appropriate function. So we're writing code, or we're writing a function that acts differently with different data types. That's polymorphism, friends. You're all a bunch of legends, and thank you very, very much for helping me get to 4,000 subscribers. Have a good one all. Cheers. See ya.